In this video, we will talk about how technology from the space race changed the world. So make sure to watch the full video. Hi guys! Welcome to a new video from RS Technology. Before we get started, make sure to subscribe to our channel. The Cold War that followed World War II, as the United States and the Soviet Union competed for global dominance, changed the world forever. And the technology from the space race continues to influence everyday life. That race began in earnest in the 1950s as both nations feverishly developed nuclear weapons and intercontinental ballistic missiles, ICBMs, to carry them, according to Air Force Global Strike. The resulting advancements in rocket technology enabled the early exploration of space, leading up to the Soviet Union successfully orbiting the first artificial satellite in 1957 and putting the first human in orbit in 1961. The competition peaked when the United States successfully landed the first humans on the moon in 1969. The legacy of the Cold War and the early space race is not just about global tension and conflict. It also yielded the birth of the modern technological age. The 50th anniversary of Apollo. With the 50th anniversary of Apollo 11 and subsequent lunar missions, many events and activities were planned around the United States, including a gala hosted by NASA at the Kennedy Space Center in July 2019. The film First Man tells the story of Apollo 11 commander Neil Armstrong at a very personal level. We can now take a look back and see how the technological know-how required to support the space race essentially built the modern world as we know it today. Life would be unimaginable without these many advancements that we now take for granted. How space has changed. Space is a different place than it was before the Cold War. For one thing, the Earth is now surrounded by a vast network of satellites, which provide continuous broadband communications and high-definition television, data used for weather reporting, navigation and positioning, and more. This is in addition to the specialized spacecraft that support scientific and military objectives. We also maintain a continuous human presence in space on board the International Space Station, in partnership with a number of countries. Space technology in everyday life. How has space technology helped us down here on Earth? Here is just a sampling of the many spin-off technologies, as NASA refers to them, resulting from space research and development that we now use in everyday life. The Global Positioning System, GPS, was originally developed by the military for precision navigation and weapon targeting purposes. The GPS developers probably did not foresee how this technology would transform almost every industry, as well as day-to-day life, on a global scale. Using maps and travel atlases and stopping to ask for directions are now largely anachronisms. GPS has enabled ride-hailing services, as well as package tracking and delivery. It has improved our fitness by tracking our workouts and our safety by quickly providing our location in emergency situations. GPS will be there in the future to facilitate emerging technologies such as self-driving cars and package deliveries by drone. Infrared ear thermometers, a NASA-derived advancement, measure the amount of energy emitted by the eardrum in the same way the temperature of stars and planets is measured using infrared astronomy technology. Artificial limbs have drastically improved using advanced space program shock-absorbing materials and robotics. Deep space exploration missions depend on excellent digital image processing technology developed by the Jet Propulsion Laboratory JPL. JPL adapted this technology to help create modern CAT scanners and radiography. The list of technology from the space race goes on. Consumer products like wireless headsets, LED lighting, portable cordless vacuums, freeze-dried foods, memory foam, scratch-resistant eyeglass lenses, and many other familiar products have all benefited from space technology research and development. Modern laptop computers are direct descendants of the Shuttle Portable Onboard Computer, SPOC, which was developed in the early 1980s for the Space Shuttle program, keeping it safe. Technology from the space race has also been applied to directly improve public safety and reduce the risk of accident and injury. Anti-icing systems allow aircraft to safely fly in cold weather. Safety grooving, which first was used to reduce aircraft accidents on wet runways, is now also used on our roadways to prevent car accidents. Smoke and carbon monoxide detectors were first developed for the NASA Skylab program in the 1970s. Modern firefighting equipment widely used throughout the United States is based on NASA-developed lightweight fireproof materials. One of the most important spin-off technologies is in the area of food safety. NASA was faced with the problem of feeding astronauts in confined environments under weightless conditions. They also could not tolerate potentially disastrous crumbs, bacteria, or toxins. NASA teamed with the Pillsbury Company to develop the Hazard Analysis and Critical Control Point (HACP) concept. HACP is designed to prevent food safety problems during production, rather than catching them after they have occurred. The U.S. Food and Drug Administration has used HACP guidelines for the safe handling of seafood, juice, and dairy products since the early 1990s. Spin it off. For more than half a century, the NASA Technology Transfer Program has provided private industry with a connection to its vast resources to support commercial product improvement development. To date, NASA says that about 2,000 spin-off commercial products have been successfully developed in many fields. But despite what you might have heard, NASA didn't invent Tang, Velcro, or Teflon frying pans. NASA continues to push the boundaries of technology on advanced programs such as the James Webb Space Telescope. JWST is being developed in collaboration with an innovative team of institutional, academic, and industry partners. One can't help but wonder what amazing new spin-offs await us. Technology and history can guide architectural restoration. First, melted scaffolding needs to be removed from the charred and broken Notre Dame before any architectural restoration begins in earnest. The scaffolding was in place for a $6.8 million restoration that was nearly completed when the fire struck. A team leading the post-fire reconstruction effort intends to remove the scaffolding in March, before beginning the painstakingly careful repair work out of fear the building's vaults could collapse. The French government, which leads the team, wants to ensure every restored artifact aligns with tradition and the expectations of future generations. Notre Dame Cathedral isn't the first, and won't be the last, historic building to be restored after falling into disrepair or being destroyed by natural disaster or war. French restorationists will undoubtedly make decisions that are informed by the spirit of the structure, but they also can seek guidance from the rebuilding of other acclaimed historic buildings and new technologies. Starting over again and again. Contemporary U.S. presidents don't actually stay in the same White House that George Washington lived in when he was in office. For one, it was then called the President's House, and, until John Adams' presidency, it was in Philadelphia. But more exactly, the building that became the White House was lost to a fire set by British troops that stormed Washington, D.C. in 1814, 2 years into the War of 1812. Although it took 10 years to construct the first White House, its architect, James Hoban, returned to the wreckage to reconstruct a new one in less than 3 years. Hoban was able to reuse stone walls, significantly hastening the rebuild, but he also saved time by altering the structural scheme of the building by using timber instead of brick, according to the White House Historical Association. Although resourceful and successfully working off memory, Hoban's expediency led to a weaker structure that ultimately led to a demolition and rebuilding of the White House 130 years later. White House reconstruction efforts pale in comparison with the many rebuilds of St. Paul's Cathedral in London. The cathedral dates to 604 AD, but it has had several incarnations after burning in several fires over the centuries. Viking raiders also destroyed it, bringing Notre Dame back to life. Modern technology now helps architects rebuild and preserve historic structures and determine how to create a restored artifact with the care and precision that restorationists and the public often expect. Infrared thermography measures the radiation emitted by different materials to create a multi-layered look inside the walls of a building. This view can show preservationists where things are buried, whether a support beam has cracked, and if anything lies beneath the surface. Ground-penetrating radar also helps detect structural defects in masonry and stone, and if any archaeological remains are buried in the surrounding grounds. What do you think of our video? Let me know in the comment section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go. Thank you for watching.